Okay, so journal 41. We're going to start out with bell work, as always. And so I have two problems up here. One is a square root, and the other one here is multiplying radicals. So let's start by just simplifying this problem here. So if I had to simplify this root, I need to know what type of root it is. If it's a square root, then it needs to have a 2 outside, right? So I like to write the number out there so I know what number I am going to be dividing with for my variables. So the square root of negative 49. Now we learned if the root is even, 2 is an even number, then if I take the root of a negative number, I'm going to get an imaginary number. But all that really means is I'm going to take the root just like normal. So the square root of 49, well, what does 49 break down into? That's 7 times 7. So in this case, the square root of 49 is 7. But because there's a negative in front of it and it's an even root, I need to put an I next to it because that tells me that this 7 is imaginary. Because I can't take the square root or an even root of a negative number. So in this case, when I took the square root of negative 49, I got 7i, an imaginary number. Okay, that was for the constant. Let's move on to the variables. So a is to the 13th power, and so we need to divide the 13 with 2, but this 2 doesn't divide into 13 evenly, so we're going to have a leftover. So I'm going to make a square root here, just in case I have leftovers. So 2 goes into 13, let's see, 6 times, so a to the 6th power, and then I have 1a left over, so I'm going to put a to the 1st power back into the root. And then b, let's see, b is to the 10th power, so 10 divided by 2 gives me 5, so b to the 5th power. And it looks like that's it. I guess I didn't need that much room here, so let me erase that. So we have just the square root of a. So I have that as my answer. So let's take a look at b next. So b, we have 2 factors, right? 2 sets of parentheses. So I need a FOIL here. So distribute. So let's take our 2 and multiply it with this 2. So 2 times 2 gives me 4. 2 times 2 square root of 3, well, that is going to be 2 times 2, negative 2, which is going to be negative 4. And then there is a square root of 3 here, so I'm going to drop that down. 2 square root of 3 times 2 is going to be plus 4 square root of 3. And then if I multiply 2 square root of 3 times negative 2 square root of 3 is going to be a negative 4. Remember, outside multiplied by outside. That's how I got the 4. Square root of 3 times the square root of 3 is square root of 9. So when I look at this, notice how these two cancel, right? Because they're opposite, they're the same but opposite in signs, so they're going to cancel. Then I just have 4, this 4, bring it down, and then I have a negative 4 square root of 9, bring it down. But hang on, the square root of 9 is 3, right? So I have actually a 3, and this 9 is right next to 4, so I have to multiply this 3 with this 4. And if I simplify, 4 minus 4 times 3 gives me 12. 4 minus 12 gives me negative 8. And so negative 8 is my answer. But I don't want to just go on to the next slide just quite yet. I want us to take a look at this last problem we just did. When we started out this problem, we had 2 plus 2 square root of 3. And then basically this one is just like this set of parentheses, only what? The signs are different, right? They're opposite. This one's a positive, this one's a negative. And so when we FOILed, did you notice that the middle terms canceled out because they end up being the exact same but opposite in signs? I just want you to just keep that in mind when we're going through this lesson here, because that's going to come in super handy. And we're going to talk more about what this is called later. So let's move on to our first slide today. Okay, so today we're going to be talking about dividing radicals, and we're going to start with something a little bit more simple, like these two. So simplifying using division with radicals, we want to split the radical from the numerator and denominator. So what does that mean? Do you remember once we tried to take the square root of fractions? Like, let's say we're taking the square root of 4 over 25. Well, what we would have to do is split the numerator and give it its own square root, and then give the denominator its own square root, and then just simplify them separately. So the square root of 4 is 2. The square root of 25 is 5. And then we can continue on whatever we wanted to do. It's just the same when we have variables. So the square root of this I can break up as z9 and give it its own square root. And then the bottom, the denominator, I can give its own square root. So square root of y to the 5th power. So the first thing we need to do is split up the square roots. So this problem here, I'm going to now try to simplify the top and bottom separately. Now, this is a square root, so I know there's a 2 outside, so I'm going to write that 2. So I know what number I'm dividing by. So if I continue on, 2 can go into 9. It looks like, well, they don't divide evenly, but 2 can go into 9 about 4 times. So z to the 4th power is outside. And then how many z's do I have left over? Just 1. So z to the 1st power back inside. Now, you don't have to write that 1 on that z, but I just did. Doesn't really matter. So 2 for the bottom here divided by 5 doesn't divide evenly as well, but 2 can go into 5 about 2 times, so y squared. And then I have 1 y left over, so that goes back in that root, so y to the 1st power. And so, looks like I have the top simplified and the bottom simplified. I can't combine z's and y's because they're not like terms, so this is my final answer. All right, let's try B. Now, I'm going to change B's problem and make it a cube, just to make this a little bit more challenging because we already did a square. So let's do a cube. So a cube root is just the same. We're going to first split up the top and bottom. So this is going to be the cube root of 5a to the 5th power and the cube root of b to the 13th power. So starting with the top here. The cube root of this number, 5, what is the cube root of 5? Let's just write that to the side here. Now, when we're trying to find cube roots, or any type of root, we want to see if we can break it down. So for a cube root, we want triples. But 5, if I were to break down 5, I can't really break it down anymore because it's a prime number. 5 times 1 gives me 5, but that really didn't do any good. So there's no point in doing that. In other words, the cube root of 5 is already simplified. So I can't do more. In other words, I'm just going to keep it in the root. So I'm making a cube root, I'm going to keep the 5 underneath it. Now I'm going to work with the a. A is to the 5th power. How many 3's can go into 5? Well, that is about 1. So a to the 1st power can come out because 3 can only go into 5 one time. But how many a's do I have left over? 2. So a2 or a to the 2nd power goes back in. All right, now let's try the bottom here. So the bottom I have, let's see, a 3 on the outside and a 13 on the inside. So how many times does 3 go into 13? Well, 3 can go into 13 about 4 times. So b to the 4th power. But do we have any left over? Yeah, we have b, just one b left over. So I have the cube root of b to the 1st power left over. And it looks like that's it. So this is my answer. Because I've simplified the top and I've simplified the bottom. A and B can't combine. So I'm done. Let's move on to the next problem here. All right. So now we are on to our last slide for today, and we're going to be talking about simplifying using conjugates. So whenever we get a problem like this, you'll notice that I have a square root in the denominator, right? And there's a minus sign. Sometimes I have plus signs. So anytime you have a square root in the denominator and plus or minus signs and you're trying to simplify, you want to multiply by its conjugate. And let's talk about what conjugates mean. By the way, I have a typo here. This should say multiply. So if you refer back to the first semester that we talked about conjugates during when we were learning about imaginary numbers, we talked about when we have something like, let's say 2 plus 3i, the conjugate of this would be 2 minus 3i. Basically, it's the same expression, but we flip the sign in the middle, okay? So that was last semester. This semester, we are going to be talking about radicals. So if I have an expression with radicals in it, like the square root of a plus the square root of b, well, the conjugate, it would be the square root of a minus the square root of b. All I'm doing is flipping the signs. So these two are conjugates of each other, okay? And so we need to find the conjugate of the denominator, because if you remember what happened in the bell work, when we multiply something by its conjugate, the radicals or the roots cancel, right? So then we don't have to worry about roots anymore. So let's find the conjugate of our first problem. So part A, we have the square root of 3 minus the square root of 2. So the conjugate would be the square root of 3 plus the square root of 2. Basically, it's just the same expression, just flip the signs. But if I multiply the bottom by the conjugate, I have to multiply the top by the same conjugate, right? Anything you do to the bottom, you got to do to the top when it comes to a fraction. So this here, if I want to multiply this out, I'm going to put some parentheses around here just to make this flow a little nicer, and I can see that I have to FOIL. So 6, when you multiply fractions, you multiply them straight across, right? So 6 times square root of 3. We learned yesterday how to multiply radicals. So this 6 will be outside of the square root of 3. 6 times the square root of 2 is going to be 6 square root of 2. And so that is our top part. Now let's try distributing or foiling the bottom. So I have the square root of 3 times the square root of 3. They're both square roots, so I have to multiply the inside. So that's the square root of 9. Square root of 3 times the square root of 2 is plus positive square root of 6, right? 2 times 3 gives me 6, and they're both under root, so they go, that's why we have a square root of 6. And then I have the square root of 2 times the square root of 3, but this one's a negative, so negative square root of 6. Negative square root of 2 times square root of 2 gives me a negative square root of 4. So when I look at this and simplify, the bottom here, notice these two, they're both square roots of 6 and they're opposite in sign, so they cancel. The bottom also, let's rewrite our fraction here. The bottom here, this is a square root of 9. What's the square root of 9? Well, that's just 3, right? So if I cancel this and made this a 3, because the square root of 9 is 3, square root of 4 is 2, so now I just have a minus 2. So what's 3 minus 2? 1, right? And so the top here, can I combine these two, square root of 3 and square root of 2? No, because we learned yesterday in order to add radicals, they have to have the same radical or the same root. In this case, this one's a 3, this one's a 2, so I can't combine these. So I'm just going to bring them over. And now when I look at this here, notice that I have no more roots underneath the denominator, which is great. So now I can divide the top by 1. So if I divide each component by 1, this is 6 divided by 1, which gives me 6, radical 3. And then this 6 divided by 1 gives me 6, square root of 2. And so that is my answer. All right, one last problem left. We're going to take it one more time with using that conjugate and trying to simplify this down. So the conjugate of this denominator is square root of 3 minus 6. So I have to multiply the top and bottom by the square root of 3 minus 6. I'm going to wrap parentheses around here so that I can see I have to FOIL. And we're going to FOIL this out. So the top part here, we have 9 times the square root of 3, which is 9 square root of 3. 9 times negative 6 is negative 54. see, negative 2 square root of 3 times square root of 3 is negative 2 square root of 9. Negative 2 square root of 3 times negative 6 gives me positive, let's see, 12 square root of 3. So that's for my top. The bottom here, I have the square root of 3 times the square root of 3, which is the square root of 9. Square root of 3 times minus 6 is minus 6 square root of 3. Then I have 6 times the square root of 3, which is plus 6 square root of 3. And then last but not least, 6 times negative 6 is negative 36. Okay, so when I look at this problem here, notice that, again, the bottom, when you multiply the conjugates, these are both the same, and they're opposite in sign, so I know I can cancel them. And so now I have, let's see, the bottom here, I have a square root of 9. Square root of 9 is just 3. So I can cancel that out and just make that a 3. What else could I do? This here is also a square root of 9, so I'm going to replace that with a 3. See if I can make some room here. I'm going to scoot this to the side. So I have 9 square root of 3 minus, well, let's see, minus 54. This here is a negative 2 times 3. So negative 2 times 3 gives me negative 6 plus 12 square root of 3 over, what's 3 minus 36? Well, that's just negative 33. Okay, so these two are both numbers, right? So negative 54 minus 6 is going to be, let's see, negative 50, let me redo that, negative 60, right? And then I'm going to bring down my 9 square root of 3 plus 12 square root of 3 over negative 33. Now, some of you might have been like, hey, Miss Shang, there's a square root of 3 and another square root of 3. Those are like terms. We can combine them. And yes, you are right. So in this case, I can combine these two here because they both have the square root of 3. So I'm going to go ahead and do that. So I'm going to make some more room. So 9 plus 12 gives me 21 square root of 3 minus 60 over 30, negative 33. Now you could stop here, but if you don't see your answer and this is multiple choice, you might need to simplify more. And so what that looks like is, well, you need to divide everything by, so you're going to need to divide everything by negative 33. So if I divide this guy by negative 33 and this one by negative 33, let's see. That would be 21 over negative 33 square root of 3. Notice that I just made it into a fraction. And then negative 60 divided by negative 33, well, that makes a positive 60 over 33. And so what I'm going to do next is I am going to find some like terms. So what divides into 21 and 33? Now, some of you might say 3. So 3 can go into 21 7 times. 3 can go into 33 11 times. 3 can go into 33 11 times. 3 can also go into 60 20 times. So I can reduce this down to 7. So 7 negative 11 square root of 3 plus 20 over 11. And so I would look at it again to see if I can reduce it any more, but it doesn't look like it. 7 and 11 don't have anything in common, neither just 20 or 11. So this is my final answer. All right, we're done.